എന്താ മാം?
Good evening.
മാം, എനിക്കൊന്ന് നെറ്റ്വർക്കിന്റെ പ്രോബ്ലം ആയതുകൊണ്ട് നമ്മൾ തുടങ്ങാൻ താമസിച്ചാണ്. കുട്ടികൾ ഇനി വരുന്നേ ഉള്ളൂ മാഡം. നമുക്കൊരു 2 മിനിറ്റും കൂടെ നോക്കിയിട്ട് സ്റ്റാർട്ട് ചെയ്യാം മാഡം.
കുഴപ്പമില്ല, അവര് വരട്ടെ. പിള്ളേർക്ക് എത്ര ക്ലാസ് ആയി?
ഇതിപ്പോ 23-ാമത്തെ ക്ലാസ് ആണ് മാഡം.
ആകെ 30?
അല്ല, ഇനിയിപ്പോ ഇനിയൊരു 3 ക്ലാസ്സും കൂടെ ഉണ്ട് മാഡം. ഇനി തമ്പാൻ സാറിന്റെ, ജയശേഖർ സാറിന്റെ, പിന്നെ സ്റ്റാറ്റിസ്റ്റിക്സ് ഒരു ക്ലാസ്സും കൂടെ കുട്ടികൾ വേണമെന്ന് പറഞ്ഞു. അപ്പൊ ഇനി 3 ക്ലാസ്സും കൂടെ മാഡം. അല്ല, ഇനി നാഗരാജ് സാറിന്റെ കൂടെ ഉണ്ട്. സോറി മാഡം, 4 ക്ലാസ് ഉണ്ട്. വിറ്റല്ല നാഗരാജ് സാറിന്റെ കൂടെ ഉണ്ട്.
മിക്കവാറും എല്ലാം കഴിഞ്ഞു വന്നിട്ട്.
അതിങ്ങനെ മുരളി സാറ് ഓർഡർ ആക്കി, പ്രസന്റേഷൻ ഓർഡർ ഒക്കെ തന്നിട്ടാ സാറ് പോയത്. മുരളീധരൻ സാറേ,
ഇതിപ്പോ ലൈവ് പോവാണോ അത്?
അല്ല മാം, ഇത് ആൽബിൻ ഒരു കുട്ടി ഉണ്ടായിരുന്നു. അപ്പൊ അയാളാണ് ഇത് ചെയ്തോണ്ടിരുന്നത്. അപ്പൊ അയാൾക്ക് സുഖമില്ലാത്ത കാരണം.
അറിയാം എനിക്ക്. അല്ല, ഇവിടെ ലൈവ് എന്ന് കാണിക്കുന്നത്, അതുകൊണ്ട് ഞാൻ ചോദിച്ചത്.
അയ്യോ, ഇത് ലൈവ് ഓൺ യൂട്യൂബ് ആക്കിയോ? അപ്പൊ
അതാ ചോദിച്ചത്.
ഓക്കെ മാം, അത് ജസീം ചെയ്യുന്നുണ്ടാവും. പ്രശ്നമില്ല, നമുക്ക് 2 മിനിറ്റ് കഴിഞ്ഞിട്ട് നോക്കാം മാം. Ma'am, shall we start the session, ma'am? The other children, I think the other students will join. എന്താ മാം?
കേൾക്കാം
മാം, നമുക്ക് തുടങ്ങാം.
തുടങ്ങാം.
So, dear students, today is good evening to all of you. Today we have our resource person as Dr. Anita Kumari. She is a principal scientist in agriculture extension at ICRCPCRI Regional Station Kayankulam. Saying a few words about her. Madam was involved in the participatory technology transfer approaches among small and marginal farming communities, and also for gender research, training, evaluations, and evolving participatory technology delivery mechanisms in coconut-based smallholder systems. And she was the main person behind evolving area-wide community approaches for coconut pest and coconut pest, especially this rhinoceros beetle, as well as coconut red palm weevil, and the management of ICT in plantation crops. And she was also involved in developing Android-based interactive mobile application named eKalpa on coconut, arecanut, and cocoa. And saying a few words about her skills and expertise, Madam's region of interest are impact assessment, farming systems, innovations, and then extension approaches for coconut, and agriculture extension and cropping system. And Madam was had a number of external projects to her credit. And her Farmers First program is a prestigious project in the institute as well as an ICR system. And she had a large number of new publications, book chapters, etc. to her credit, and a number of training programs for the students as well as the farmers. And we are really lucky enough to have her as our resource person today. Madam, kindly start the session, ma'am.
Thank you, Dr. Neema. And also, good evening to all the participants. And I will make the presentation very short and brief. Are the slides visible?
Yes, ma'am. Slides are visible. Ma'am, please on your video, ma'am, so that the students can see you, but they can know who you are. Yes, ma'am. The slides are visible, ma'am.
They are moving also, isn't it?
Yes, ma'am. It is moving.
Okay, then we'll go straight to the topic, I think. And I'll be sharing some of our experiences in CPCRI on the innovations in extension delivery mechanisms, mostly on coconut only. And I'll be presenting some 3 cases on it. And once again, I welcome you all to this session. And you all know about our Central Plantation Crops Research Institute with headquarters at Kasaragod. I am working in the regional station at Kayankulam. There is also another regional station in Karnataka and 3 research centers. And we have an all India coordinated research projects on palms with 30 centers and 2 Krishi Vigyan Kendras, one in Kasaragod and one in Alappuzha also. So this presentation is divided into 3 parts. The first will be on technology transfer and utilization among the coconut farmers. And the second will be on why we need some innovative extension mechanisms in coconut. Why can't we go with our traditional method? What is wrong with it? And what are our experiences? So I'll make it short to you. And on the first part regarding the knowledge and adoption of coconut farming technologies, during the previous sessions, you would have heard many technologies, both software and hardware also from in different sections, that is in different divisions of crop production, crop protection, then value addition, and so on and so forth. So in several studies conducted by the social science division, we have seen that the knowledge and adoption are more or high in the use of organic manure, basin opening, and cultural operations. All these are connected with the traditional practices. Maybe in other crops also this will be of the same fashion only. a medium level knowledge and adoption in the case of chemical fertilizer application, pest management, and very low, or in some cases it is almost nil in the case of biocontrol aspects of pest, red palm beetle management, adoption of hybrid varieties, and integrated management of root wilt disease. The reasons and the causes are different, so I'll be taking it up one by one. The major reasons are, I have seen that so many of you are from different states, but I will be limiting my presentations to the homestead system on the small and marginal farmers. Now, in the National Sample Survey Organization data also, the fragmentation of the lands are on high in most of the states. So in the case of coconut, mostly the coconuts are cultivated on a homestead system basis. That means not only coconut will be there, other crops and other enterprises also will be there for the household as well as a little for the marketing also. Not on a full commercial scale. It's an ecological system also. So the knowledge need, the extension approaches, even the research outcome or output is also demanded on a different way when compared to a monocrop system or other systems. So that is one of the, it is not a constraint, but it warrants for a paradigm shift. That is what I want to tell you. And the preponderance of small and marginal land holdings. It's a phenomenon everywhere, and sometimes small is beautiful also, because you can have more intense farming, you can have an integrated farming system like that. And in our state, in Kerala, the average holding size is only 0.13 hectares, and among 96% of the farmers. But on an average, in the case of coconut, it will be 0.2 hectares. So in all these cases, the traditional extension system for the multiple crops with the general schemes by the Department of Agriculture is being followed. So that itself showed that there is a gap, there is a challenge for achieving the full potential of the extension system and also the full utilization of the research output also. So that needs some input from our social science also. So that is what I'll be sharing. And this is due to several factors, the access to the critical inputs. For example, if you are recommending biological control measures, but if the critical input is not available, what is the use of recommending a technology? And also, we are concentrating more on the individual farm-based extension. Even when I calculate the adoption also, we will be calculating based on the perceptions, based on the responses of the sample individual farmers, isn't it? So that also needs a paradigm shift in the social science research also, along with the other research. So it is getting into a complex system, and it demands a different path also. So in the classical technology adoption life cycle by Everett M. Rogers, you all would have been studied in your BSc agriculture classes. It follows a bell-shaped curve with the first portion by the innovators, then early adopters, early majority, late majority, and laggards. This is a very common thing, and it is now being applied not only in agriculture, but also in several other fields also. In most of the marketing studies, in most of the consumer studies, this is getting important, and it is very widely it is applied also. But there is a gap that you have to see in the next slide. See this. The laggards are anyway, they will be very resourceful and they will be innovators. Any technology, they will be the first one to catch it. Even if a Lamborghini car, the innovators will buy it. And early adopters also, they may buy it, like the agriculture technology. So these two categories will form 16%, isn't it? But these two are very few. So if any of our technology is being adopted by the first innovators and early adopters characteristic, it may not be due to the positive attributes of the technology. It may be due to the resource base, the high resource base, and also the innovativeness of the farmers who are adopting it. So there is a chasm in this point. So if you jump this chasm, then only that technology is getting a social proof. Usually we never used to, seldom used to used to investigate on this chasm and how to go to get the social proof. So this tipping point, only if you cover this tipping point, you can go to the early majority or late majority and the late mass, or the laggards as we used to say. So this chasm is very important in the case of technologies. For example, if a high yielding variety of coconut is being released, these two categories will adopt it or they will access it by any means, because they are resourceful, they can get it, they will have direct access to the research stations like that. But only if it is being adopted to the other categories of this bell-shaped curve, it is of a social proof, and then only we can say that the technology utilization is as expected or as envisaged. So here in short, you have to see the farmer's farm, then the innovations, because innovations are more important than the direct technology, isn't it? Because we all have a mobile phone. It's the innovation from the original phone. So that innovations are being very important in case of technology utilization among the farmers and among the society also. Then third is the resources. So the resource base is also important when you think of the paradigm in case of research or in case of extension. Then finally, the science and technology also. If these three are considered, we can push into the science and technology part to integrate with the existing innovations, with the existing resource base and the existing farmers' farm. So that's why we are now talking of the farmers' income and even the National Farmers Commission. It is not about the technology, it's not about the extension, but the farmers. So the farmers are placed in the central position. So in this Farmers First program also, this is the expansion of this first, the farm or the farmer, then the innovation, resources, science and technology. If you consider this, only then you can have innovations in technology reach out mechanism also, or the delivery mechanism also. So the first case is about the root disease of coconut, because all of you may not be very familiar with the root disease of coconut, but it's a debilitating disease which is affected among majority of the coconut palms in the state, in other states also, and it is caused by mycoplasma. So there is no absolute control measure, and since it is debilitating, it is the high risk proneness is also there, and it affects the general health and yield of the palms also. So the farmers will be having a lack of confidence, and the symptoms are also very complex. You would have heard this in the earlier classes. So as I told in the previous slide, the lack or the non-availability or the low access to the resistant and tolerant seedlings of towards this disease also one of the problem. And another challenge what we have taken in the development of the innovative extension approach is that the number of farmers we have to reach for a unit area. For example, in a hectare, there will be 10 farmers. So the 10 farmers will have different resource base, different perception, different knowledge base. So you have to evolve a participatory technology in technology transfer approach in this case. So that's how we have developed a participatory technology transfer approach for this integrated root management. And this we have taken in and around our institute in 25 hectares as a pilot scale. And you can see that the major points that we have given stress is the stakeholder analysis, because there will be direct stakeholders and indirect stakeholders also. Then the participatory assessment of the situation, participatory technology transfer, and participatory technology implementation. And finally, the participatory evaluation also. So what is the advantage in this case is that the researchers, the experts, the first line extension people, the women farmers groups, and also the coconut farmers organization and farmers are being involved in each and every step. So there is the researchers are not away from the farmers or not away from the system. So they can also learn, they can also unlearn, because whatever they have believed may be wrong in the actual field situation, and they can relearn also, and it could be incorporated in the research system as a feedback also. So it is becoming transparent and the system is getting more efficient. So what we have achieved is, so what is the result or the outcome is that we have proved that the yield could be increased, almost doubled, even though the root root disease could not be controlled per se. And the BC ratio also could be improved from 1.07 to 1.77. And several stakeholders, including the policy makers, ICR research experts, and the other scientists of agriculture universities visited the places, interacted with the farmers, and we have interface meetings, several interface meetings, and the results were convinced, and it was taken and upscaled throughout the Kerala state. And even now it is being implemented through the Keragramam programs, and there the result is getting replicated, showing the validity or the feasibility of this participatory technology transfer approaches. So here you can see that the disease intensity from apparently healthy, disease early, disease middle, and disease advanced. These are the 4 categories of root disease affected palms, how we are classifying. So you can see that it is getting reduced. That means the health is getting improved due to the integrated technology participatory approaches and also the technology implementation. So in the case of the result of the approach is that the awareness, knowledge, attitude, and adoption have been increased, and it is statistically significant also when you compare it before the participatory technology transfer approach and after the participatory technology approach. So here, in the first case, the takeaway point is that when a problem is there on a public consequences basis, you should have a social approach on that. It should be a general approach involving all the stakeholders with a participatory learning and taking the lesson from that and forming a extension delivery mechanism for such a disease, so that it gets the triangulation is there among the participants and among the stakeholders also. So that is the first case where we have done that innovation. The second case is on the rhinoceros beetle, especially the biocontrol management. You all know that the rhinoceros beetle is an ubiquitous pest, and it is being there in every coconut growing countries of the world. That's why it's called an ubiquitous also. And since it is a problem for all the growing stage of the coconut, from the seedling or the juvenile or the adult palm, it attains importance both in the case as an economic loss for the farmer, and also there is a 10 to 13% loss in the yield also. You would have heard from the entomologist. But when we have done the study on the biocontrol aspects, because classical biocontrol technologies were developed by our institute, but even in a study in 2012, we have seen that the knowledge and adoption of these biocontrol aspects on the rhinoceros beetle is very, very low, below 5%. So that may make us think to have an innovative approach with a paradigm shift from the conventional extension approaches for improving the adoption of this technology. So there, the first thing what we have done is from an individual unit of adoption to a community level approach. So this is the area where we have done it in the Trivandrum district with 520 hectares with more than 1 lakh farms and more than 5,000 farmers. So it was a complete participatory action research program involving the local panchayats, the local farmers groups, the women groups, the scientists, and the extension system. So it was a beautiful study, and there was a beautiful outcome and a very practical outcome from this interaction. And you can see that this is the approach that we have developed in this. It's a community extension approach, area-wide community extension approach for biomanagement of rhinoceros beetle. What we learned here is that for all the technologies, the general extension approach may not fit suitable. So like the appropriate technology development, we have to have appropriate extension approaches or the delivery mechanisms for making the technology utilized by the society or farmer society. So here what we have done is that we have shifted the area, shifted the unit of adoption from individual farmers to a wide area. And these stakeholders had a participation in that. So the first and foremost part is that the technology per se, that is the critical input, the metarrhizum anisoplea, that fungal agent for the biocontrol was not available among the farmers. So a technology without the critical input is as good as a technology not developed. So what we have done is that we have robbed in the women self-help groups. The scientists trained them, and the scientists have given the GMF means the green muscardine fungus, the metarhizium cultures. The skill were imparted, and we got the technology feedback also from them. So the thing is that since this is a dynamic process involving the stakeholders, because these women self-help groups themselves refine the technology, reduce the cost, made it very, very simple and practical, and they themselves provide the critical inputs for more than 6 districts in more than 6,000 hectares of coconut area. So this way, the response and the responsibility of the participant units of the society in making the technology simple and refining them. So the thinking of a researcher and the thinking of a normal farmer may be different. So they will think more practically, they will think how to reduce the cost and how to make it accessible to more farmers in a lesser time. So like that, the technology diffusion, we have robbed in the milk cooperative societies. So this GMF cultures were given to all the livestock farmers through the milk cooperative society. And another thing that we have pointed out in this approach is that usually the 4 adopter categories you have seen, but here we found a new adopter category, that is the critical adopters, because the pest or the rhinoceros beetle multiply and breed in the organic manure. That means the livestock farmers or the vermicompost units or the coir pit composting units. So per se, these farmers are not may not be directly having connection to the coconut farmers, but the consequences of if they do not adopt the technology, the utilization of the technology or the impact of the technology will not be felt by the coconut farmers. Hope you understand that. So their adoption is very critical. So if the critical adopters do not adopt it, the technology's performance will not be there. So here, that is the major thing that we have found, and that changed the whole thing. So this critical adopters, the non-adoption of the technology, but the critical adopters make the technology a failure. So in that way, we could shift the focus of the extension to the critical adopters, and also the awareness program about these things to the general coconut farmers. And so 653 critical adopters we have mapped in the single panchayat, and you see how we could reduce the time, how we could increase the efficiency of the technology adoption when we have identified the critical adopters' role in the technology utilization, and how we have robbed in the other stakeholders also. So it was for the whole panchayat, the technology cost was minimum up to 25,000 only, and we had a unit of the women self-help groups for the multiplication of the fungus, and within 2 months 90% of the critical adopters could be reached, and the technology adoption was very, very effective, and the impact was also there. So the scattered breeding sites were mapped, and we have concentrated on these 643 critical adopters. So it's very simple, and this coordinated efforts make 85% of the critical adopters we could reach within 2 months, and the adoption of the technology was made very simple and straightforward also. The cost also, the women groups could reduce the cost by 40%, and also the time for evolving the technology also, for producing the metarhizium also, they reduced by 30%. So this is the impact when we have a community participation in technology refinement. So that also made a very critical role in making this technology adoptable and utilizable for the entire coconut community of more than 6 districts. So another thing due to this innovative extension approach is that usually our institute used to recommend this practice once in 3 years, because in the lab condition or in a controlled condition, the metarhizium fungus spores found to be very active up to 3 years. And the farmers used to take the manures during every March, April month only. But in the when in the practical situation, we could find that every year we had to apply the metarhizium as a treatment in the rhinoceros breeding sites of the panchayats or the livestock farmers manure pits. So like that, we could change the recommendation also from once in 3 years to once in a year. So this is the second example. And you see, it's a very simple method. They have refined it, the multiplication of the metarhizium fungus with a very minimum facility. The contaminations also were very less. And this is the refinement that the farmer groups have done, because they have removed this cotton and also this pipe, and then they have just made it very simple. So like that, they have reduced the cost also through this refinement. This is the simple thing they have done. They have folded it, just stapled it, and it is over. So likewise, they have refined it also. And this is the women group members became master trainers for making other farmers of other districts of the state also in having the skills of multiplication of this metarhizium fungus in very minimal condition with the maximum efficiency without any contamination also. So these are the different stages of the pest, what we got from the panchayat. See, this is the grub infested with the green muscardine fungus or the metarhizium. Even the adult beetles were also found to be infested. So we used to get the trap, and we used to trap the infested beetles also from different places. So this also showed that the adult beetle also play a role in transferring the fungus or the biocontrol agent to different breeding sites by the natural behavior. This is the egg of the rhinoceros beetle. So this is the result. That is the adult bearing palms. Before and after, you see the difference. So this much reduction in the case of rhinoceros beetle infestation, but in the non-intervention area, it was almost on par. There was no statistical significance. In the non-bearing palms also, it was getting reduced when compared to the non-intervention area. But one surprise outcome of this was, in the intervention area, the infestation in the among the seedlings was found to be more when compared to the non-intervention area. So this participatory innovative approach also made that when you have a community-based area-wide biocontrol measures, you have to have very keen and very strict adoption of technologies in the seedlings for preventing them from more
Madam, are you online? Anita ma'am? Anita ma'am? Am I audible? Students, am I audible?
Yes, ma'am, you're audible, ma'am.
Oh, so I think there is some network issue with Anita ma'am's side.
Yes, ma'am.
Yeah, I'll just call her. Please wait.
അല്ല ഇത് അങ്ങോട്ടാക്കാൻ പറ്റും സ്ക്രീൻ. So can you hear Nima?
Ma'am, I can hear you. I can see you, ma'am, but not the slides.
Because I joined from my mobile phone.
Okay, ma'am.
This slide. So in the case of red palm weevil, which is a very fatal pest of coconut, the approach should be different. So we have done this approach in an area of 2,000 hectares in an entire panchayat for 2 years. One minute. 849 49 13 69 50 6950 849 849 849 49 pinne 13 69 50. Okay. KGRP 2. KGRP 2. Okay.
Ma'am, we can see you in both, ma'am. So laptop is also on, no, ma'am? Ma'am, you're mute in your, yes, ma'am. It is okay, ma'am.
Okay. Can you enable sharing? Post disabled.
Okay, ma'am. I will do that, ma'am.
Can you hear Nima?
Ma'am, I can hear you, ma'am.
Then I will complete.
Because Jassim is a host, ma'am. I am asking, just trying to contact him for the enabling.
No problem, no problem. I will complete anyway.
Okay, madam.
So in the case of the red palm weevil, we have done the intervention in 2,000 hectares for 2 years in a total farm holding of more than 7,000, involving more than 1.75 lakhs of coconut trees. So here we have to have a different approach, unlike the other rhinoceros beetle, because there the community adoption with involving the critical adopters was very much sufficient for the successful implementation of the technology. But in the case of red palm weevil, the individual responsibility should also be there for having a positive social consequences. Why? Because unlike the rhinoceros beetle, their breeding site, you can have the technology application. But in the case of red palm weevil, the whole 4 stages of the coconut pest will be within the host plant, that is the coconut. So it should be the individual as well as the community approach. So the individual responsibility or the individual awareness, individual knowledge, individual skill should be in the symptom identification and also in the case of the technology application. But the case,
sorry to interrupt, ma'am, but now you can share the screen, ma'am. Share the slides because now you have been made the co-host, madam, so you can share the slides.
Is it visible now?
Yes, ma'am. It is visible, ma'am.
Okay.
Thank you, ma'am.
So as told in this case, the individual responsibility should be to be aware of the technology, should be the adopters of the technology, should identify the palms with the symptoms, and also should have the responsibility to have timely adoption also. Because this, even if there is a single palm of infestation in your plot, in your garden, you are that coconut palm will be responsible for the dispersion of the pest to other coconut also if you are not adopting the control measures very timely. If the coconut palm is also dead, and if you are not removing also, it is also will be a reason, will be a cause for the spread of this deadly pest, causing complete yield loss and complete the palm loss also to the small farmers. So here the individual as well as the community responsibility should be integrated or should be converged together for having a successful technology utilization in this case. So here the individual thing also, in the case of individual farmers also, we had the extension interventions and have a social responsibility also with the groups. For example, the participatory documentation of the red palm beetle infestation in the area, the mapping of the red palm beetle affected palms in the area, then formation of the coconut plant protection surveillance group, because just like the COVID, the surveillance of these infested palms in an area is very, very, very important. Why I am stressing on these points are sometimes the technology per se is not very critical in having a success. The other factors also should go hand in hand for the successful outcome or output of the technology also. That's why I'm stressing on these points. So in this case, we had integrated coconut field clinic also on a decentralized basis also. So we have dropped in all the possible awareness building programs with the print, mass media, video films, television programs, radio programs like that. So here the leadership skills also is required for the group facilitation, for example, the master farmers, the surveillance and all. So we learned a lot by being along with these farmers for the identification of the red palm beetle and also the adoption, the timely symptom identification, or many new symptoms also we could earth out with the participation of these farmers. So this is the infestation. This is the mapping that we have done. With the GPS, we have plotted each and every red palm beetle infested palms, and likewise we have formed a sampling method, also rapid sampling method also for assessing the severity of the infestation in an entire panchayat. You can see the colors here, it shows the severity, and also after the intervention, you see how the technology output is being very successfully felt by the farmers. So likewise, the simple takeaway is that there should be refinement, there should be application of the social theories, and there should be a paradigm shift based on the problem, based on the biology of the pest, or based on the disease characters like that, for the success of the technology utilization among the farmers. So the relevant role of the extension scientist or the extension research is also being stressed by these methodologies, by these innovative extension delivery mechanism among the farmers, especially among the small and marginal farmers. This is applicable for all the other crops also, especially among the smaller, because the number of farmers to be reached out will be more in this case. Then the extension approaches needs participation, social convergence, linkages and all for effectively reaching out to the technologies with the correct or accurate technology base also. So these are some of the photographs of what we have done. The scientists taking classes and all the awareness programs. Even the women, young ladies also participated in the control measures. Then the destruction of the infested palms. It was a very huge process in almost 2,000 hectares with the participation. It was a 100% participatory program and a very, very high learning experience for us also. See, in each and every plot, there was a team in each ward. So like the 21 teams were there for the surveillance, and also the application of the chemicals or like that. Then and there itself, like this, we have coordinated the activities. These are in continuation. There was an interface meeting of the department, ICR, and local panchayats also about the results, and also a feedback from the farmers also, so that it will be transparent and the triangulation will be very, very effective in deriving out the final innovative approaches for scaling down, for focusing down on the final innovative extension approaches. These are the participatory survey. See, the farmers also, they were documenting the survey and all. So this ultimate result, this blue thing was the coconut area in the panchayat. Here the rubber was there, paddy was there in between. So you see the difference also in the other wards also. So this is the final innovative approaches what we have developed with the social institution, community organization, research and extension agencies, and activity-based skill groups. This activity-based skill groups was not needed in the other case. So there should be a customized innovation for delivering the technologies according to the problem and according to the technology base also. So this is the difference. You see the color difference in the GPS mapping in an area-wide red palm beetle infestation. And you see the severity has been reduced to minimum level in the second map, you can see. So this is the incidence in case of the percentage, because if the red palm beetle incidence is more than 1%, we should go for an area-wide community approach. That is the regression equation we could get from this very huge data. So that way also the innovative extension approaches could give the feedback to the research mechanism also for deriving the technologies, because the same approach is not needed when the pest incidence is very severe and the pest incidence is very low also. The approach will be little different at that time. And finally, we had the ICT with the eKalpa. There are several mobile applications for several crops, livestock, tell. This available, eKalpa is available in the Play Store. If you are interested, you can also download. And this is the different part, that is the farmer support. So in this farmer support, it is online only, you can available online only. So in this farmer support system, you can just open it, and in the field or anywhere that problem, wherever you are seeing, you can have the podcast, you can have a photograph, or even you can have the mobile video also, and you just click on that, and there is a tick mark on the base of that. You just touch the tick mark. Within seconds, it will reach the CPCRI admin unit, so that the scientists themselves can give the solution then and there itself. So this is an interactive cloud-based mobile application, and any farmer, even if online facility is not there, he can have in his he can take the video or the image. Whenever there is online facility, he can upload it to in this system, and the scientist can answer the this thing in any language, in the local language or this. And another thing is that along with the uploading, the GPS measurement, the IP number of the application, everything is also being documented, so that in a future time you can have the mapping of the problems, the field problems on a national level basis based on this data, and it can also serve for a database for timeline analysis, or the databases of an emerging technology in any area. So this can be used as a feedback tool also for the research and extension system. So that is the innovation in this eKalpa we have done. And that's all in very brief, and thank you so much. So in brief, what I'll be happy to answer any doubts are there.
Thank you, ma'am. Ma'am, you can close the slides, ma'am. Stop sharing. Students, we are by ma'am's class. I think you would have understood how this research orientation, how the extension tools has been oriented in a has been useful in research and helpful in the bridging the gap between the research activities as well as the farmers. Excuse me. So if you have any doubt, you can ask to Anita ma'am. The session is opening for discussion. Students, no doubts?
I think because of the interruptions in between and all.
No, ma'am.
That is there in the online, this thing, it will be there.
Yes, ma'am. Yes, ma'am.
Now, the only simple point of takeaway is that just like the appropriateness of technology, there should be an appropriateness of the extension approaches also in relation to that characteristic of the technology, the problem, the biology of the pest, or the disease characters like that. So usually we used to have a single bus to go anywhere like that in the extension system. So that is not the present shift in paradigm that is being warranted is very different, particularly among the small and marginal farmers with emerging problems, especially in this climate change also. This participatory extension approaches are needed very much. Innovative delivery mechanisms are needed very much because the climate change also will be different in different areas.
Yes, ma'am. I'm thinking what happened to our students. They are not asking anything. Usually they used to ask doubts and clear it.
No
I
problem.
think since it is extension class and madam's class was very clear and they don't have doubts, I think.
No problem. No problem. Thank you so much.
Okay, ma'am. Thank you. Thank you very much, ma'am.
Thank you.
For accepting our invite and being a resource person in our program. And thank you also your dear students for participating in the program. So have a
Sure. Thank you.
Good evening. Ma'am, 1 minute, ma'am. Actually, Puneet is, okay, Puneet is telling he's thanking you, thanking ma'am for all the information. So Puneet, you don't have any doubt to ask to ma'am?
Now, I think maybe just because it is connected with coconut also. But only I want to drive that idea of having a different innovative delivery mechanisms in extension as per the problems, as per the situation. That's all.
That is clear in your presentation, ma'am, that how this the extension research can be diversified and for the benefit, so that the research for the benefit of the farmers as well as bridging the gap, ma'am. So that was clear from your slides and the research methodology.
Thank you. We'll
Find it. Thank you, ma'am. Thank you very much. Thank you, student.
Thank you.